We are still looking at the differentiation of trigonometric functions, and now we're going to look at the product rule. How you're going to apply that to trig functions. Now, the product rule states that if you differentiate a function with, and this function consists of two functions in it, then what you do is you differentiate the first function, the fx, and you multiply it with the second function. But then what you do is you add the multiplication between the first function, the fx, and the derivative of gx. This is the product rule, and again, it's difficult to imagine it, so let us do a couple of examples to see how we will apply this product rule to trig functions. The first example is if you differentiate in terms of x sine x, and then that's the fx, that's the first function, and then you have 5x squared plus 2x, so that's the gx. Okay, now when you start differentiating, you get rid of that notation. So first of all, we need to differentiate, get the derivative of sine x, and that is just cos x. Okay, so you put the cos x there, and then you need to keep the gx first, and then you add, then you keep the original fx, the sine x, you just keep there. So you kept that one there, and then you need to get the derivative of that to multiply it with the sine x. Now if you get a derivative of 5x squared plus 2x, it's just 2 times the 5, it's 10x because you also subtract 1 from the 2, plus, and if you get the derivative of 2x, is just 2, and that is basically your answer. Now you've done the differentiation. But let's look at another example. Let's move this a bit down. Okay, so another example. Oh, this is arc. Let's try arc tan 3x times x squared plus 1, and again this arc tan 3x, that's the fx, and this square root x squared plus 1 is the gx. Okay, what will we do now? Well, first of all, we need to get the derivative of that one first, and the derivative of arc tan 3x, it's 3 over, and this is standard. Hey, standard. Let's, before we give the answer so short, yeah, it's just straight like that. Let's try to work out arc tan 3x on its own first before we go ahead. So if you have the fx as arc tan 3x, okay, when you get the derivative of that, this is now standard. Well, arc tan's derivative is just 1 over 1 plus, and it would have been x squared if there was an x, so you need to put a 3x squared in there, but then you multiply with this one's derivative. Remember, that was the chain rule, so you get a derivative of the big function and you multiply it with the smaller function's derivative, and 3x derivative is 3, so the answer will be, well, this is actually 3 over 1 then, and if you multiply two fractions, you multiply top, multiply bottom, so it's 3 over 1 plus 3x squared. Okay, I think let's even do the square root x squared plus 1, and if you rewrite that, it will be x squared plus 1 to the power of a half. Okay, now if you get the derivative of that, you times the half to the front, x squared plus 1, and you minus a 1 from this, so it will be negative a half, then you times with the inside. This is again the chain rule, so you differentiate the big function and then you multiply it with the derivative of the inside function. Now if you derive and get the differentiation of that, it's just 2x. Okay, so 2x times a half is 2x over 2, so it will just be x squared plus half minus plus 1 to the power of minus or negative a half. Okay, now we can solve this dx. If you go from there, we're going to continue from the dx there. So if you get the derivative of that now, what you will do is, well, you get the derivative of fx, and the fx is just 3 over 1 plus, sorry, just remember here, that's square root, or that 2 there, the square must be outside the bracket. So if you square it inside, you'll just get 9x squared. Okay, so this was the fx that you derived. So this is the f accent x, and then you multiply it with this straight away with the gx. So this will be x squared plus 1. Then you have the plus. Now you just write the fx again, because this is now the product rule, and you multiply it with the gx derivative, and it will be this one. So you times it with x squared plus 1 to the power of negative a half. That's your answer. You don't usually need to simplify it further. It's always good practice to make all your exponents that are negative positive by taking it underneath the line. Okay, but that is the product rule for you applied to trigonometric functions.